Hello. First of all, thank you, ma'am, for doing this. So, the topic that I've chosen is entropy or second law of thermodynamics. The law can be stated in various ways. One by Clausius is that heat can never flow from colder body to hotter body. The Kelvin Planck statement states that it is impossible to create 100% efficient heat engine. And the entropy statement, which states that the entropy of a closed system can never decrease over time. Entropy is the reason why glass shatters, coffee and cream mix together, and ice melts. Entropy is the measure of disorder or randomness in a system. So let's look into the history of entropy, how the concept of entropy came into picture. In the early 19th century, engineers were concerned about the efficiency of heat engine, especially French engineer Sadi Carnot. His work laid the foundation for the development of second law. Then came Rudolf Clausius, a German physicist who formalized the second law of thermodynamics in the mid-19th century. In 1850, Clausius introduced the concept of entropy. Lord Kelvin then made significant contribution to the understanding of thermodynamics. He proposed the concept of absolute temperature scale, now we known as Kelvin's scale. He articulated the second law in terms of impossibility of a perpetual motion machine of second kind. So how does the entropy work? Why does the hotter body tends to cool some over time and the colder body tends to heat up? The best way to describe entropy is as disorder. It is associated with things becoming more mixed, random, and less ordered. The best way to think about entropy is as the tendency of energy to spread out. Let's imagine we have two boxes and six balls. The number of ways in which we can arrange all six boxes in one box and the other box empty is one. We can keep five different balls in one box and one ball in the other in six different ways. Similarly, we can arrange four and two balls in each boxes in 15 different ways. And the possibility of having the same number of balls in each box is 20, which is higher than any other combination. Now, if we take these balls as energy or heat and the boxes as a body, we can see that it is less probable for heat to flow from colder to hotter body than to maintain the temperature between the two bodies. Now, let's see an example at a molecular level. Now we have two metal bars. One is hot and one is cold. And zoom in a little bit so we can see the atoms of it. Here let's suppose eight atoms both have numbers of vibrating energy packets. The hotter the bar, the more energy packet it has. Again here let's say the hot bar has seven energy packets and the cold bar has three. These energy packets are from atom to atom in the lattice of the bars. When both the bars are brought together, these packets hop from atom of one bar to the other. Now, if we take a snapshot of this hopping of packets, we might get nine energy packets in hot bar and one packet in cold bar. How is this possible? How did the heat flow from cold body to hot? Well, this is where Ludwig Boltzmann made an important insight. Heat flowing from cold body to hot body is not impossible, it's improbable. The ratio 9 is to 1 is very unlikely than the ratio 5 is to 1, as we have seen in the previous example. And we are talking about atoms, which are far more than 8, and the energy packets are also far, way more than 10 universe. As the number increases, the ratio difference increases. So the ratio of not having the same number of energy packets is so unlikely that it never happens. Scientists believe that the entropy at the beginning of the universe was at its lowest and has been increasing ever since. Entropy increases means the disorder in the universe increases. The sand grain in a beach is at a high entropy. It cannot itself form a sand castle because that would mean decreasing the entropy. To decrease an entropy somewhere, we have to increase it somewhere else much more. Entropy answers many questions of the universe, like why do shattered glass do not go back to normal? Why we cannot have 100% efficient heat engine? And why does time only flow in one direction?